Here is our third and final example for finding a second derivative using implicit differentiation. This one's going to be a little bit longer because there is a product involved in the original function. So let's start with our first derivative. To do 4xy, I need to break that apart into 4x times y. Keep the 4 with the x to keep it a little bit easier on yourself. So the derivative of 4x is 4. Keep the y the same. Plus, now do the derivative the opposite way. Keep the 4x. Do the derivative of the y to get dy dx. And that's the derivative of 4xy. Now we need to do the derivative of y squared. Well, that will be 2y dy dx. And that's equal to the derivative of 6x, which is simply 6. Now I need to go through and solve for dy dx. So I'm going to start by subtracting 4y, and I'm also going to factor out the dy dx at the same time. So we're going to subtract 4y to make that go away. And then I'm going to factor out the dy dx's at the same time. So I'm going to end up with dy dx times 4x plus 2y is equal to 6 minus 4y. And now I'm going to go through and divide. So I get dy dx is equal to 6 minus 4y divided by 4x plus 2y. And now here's what I noticed. Look at all of these coefficients. See how they're all even? Since everything is even, I can go through and divide the top by 2 and the bottom by 2 to reduce a little bit further. So we're actually going to use the first derivative is 3 minus 2y over 2x plus y. So there is our first derivative. Now that we have our first derivative, we need to find the second derivative. This is going to require the quotient rule. So, second derivative. D squared y dx squared is equal to, we're going to use the quotient rule. Low, 2x plus y. D high, the derivative of 3 is 0, the derivative of negative 2y is negative 2 dy dx. Minus high, 3 minus 2y. D low, the derivative of 2x is 2, the derivative of y is dy dx. All over low squared. 2x plus y quantity squared. Now we are not going to FOIL this out. We're going to leave it as 2x plus y quantity squared for the entire problem. So what I'm going to do next is I am going to go through and replace all of my dy dx's with their equivalent expression. 3 minus 2y over 2x plus y. And this is where things are going to start to get a little bit messy. So here we go. Our second derivative will be 2x plus y times negative 2 times 3 minus 2y over 2x plus y minus 3 minus 2y times 2 plus 3 minus 2y over 2x plus y. Again, all over 2x plus y quantity squared. Now the first thing that I notice is related to the first term. I have 2x plus y times negative 2 times a fraction. But what's going to happen is the 2x plus y on the bottom here is going to eliminate with this 2x plus y. So I can rewrite that first term as negative 2 times 3 minus 2y. So I'm going to make that negative 6 plus 4y. This is what the first term reduces down to. Unfortunately, the second term doesn't work out quite as nicely. So what I'm going to do is keep the 3 minus 2y as it is for now. And I'm going to figure out what this second set of parentheses is by getting a common denominator. So I'm going to take that 2 and multiply it by 2x plus y. And that's going to give me 4x plus 2y plus 3 minus 2y over the common denominator, 2x plus y. Remember, this is still all being divided by 2x plus y quantity squared. Now I'm ready to get rid of the fact that I have a fraction inside of a fraction. Like we have before, we're going to focus on the numerator in the top. I'm going to multiply by 2x plus y on the top, and I'm going to multiply by 2x plus y on the bottom. So when I do the 2x plus y here times the negative 6 plus 4y, I need to FOIL. But when it comes to the 2x plus y times this big, long second part of my numerator, it's just going to get rid of the denominator for me. So this is essentially going to disappear. And then the denominator for the entire function will become 2x plus y quantity cubed. Let me show you how that's going to work. Although before I show you how that multiplication works, if I look at the big, long fraction I just came up with, I see two like terms. I see a plus 2y and a minus 2y. Those I can eliminate off to make that just 4x plus 3, which is going to be a little bit easier to look at. So now for the big, long multiplication. Here we go. What I'm really going to end up with is this. Negative 6 plus 4y times 2x plus y minus 3 minus 2y times 2x plus y. Oh, I'm sorry, not 2x plus y. Times 4x plus 3 all over 2x plus y quantity cubed. Keep in mind that nothing here can reduce yet because the numerator, although it has some factors, is not factored completely because of the minus sign in the middle. So I need to FOIL everything out before I could try reducing anything. So when I go through and FOIL, I'm going to end up with this. Negative 12x minus 6y plus 8xy plus 4y squared. Then I'm going to have to subtract the second FOIL. So I'm going to get 12x plus 9 minus 8xy minus 6y. Remember, that's still all being divided by 2x plus y cubed. Don't forget to distribute this minus sign to every term in that second set of parentheses. So let's see if we have any like terms here. I have negative 12x minus 12x is going to end up giving me negative 24x. So those two terms are now gone. I have negative 6y minus negative 6y. those are just going to completely eliminate, and I won't have any plain y terms left. Now I have positive 8xy minus negative 8xy gives me plus 16xy. And now those are taken care of. And the last two terms that I have are not like terms, so I'm just going to write them down. Plus 4y squared minus 9. Don't forget you're distributing the negative sign. And now I still have the 2x plus y quantity cubed on the bottom. So we've done a lot of algebra so far, but we're still not 100% done. At this point, once it looks like we've simplified completely, we need to go back and look at what our original function was. So here's a reminder. Our original function was 4xy plus y squared is equal to 6x. Question is, can I use that at all? What I want you to do is focus on the first three terms. We're not going to worry about the minus 9 right now. The first three terms have a GCF. I'm going to factor out a 4. So that's going to give me 4 times negative 6x plus 4xy plus y squared. Then I have this random minus 9 at the end, but that's okay. 2x plus y quantity cubed on the bottom. And now I see something familiar. Now I have 4xy plus y squared. 4xy plus y squared was equal to 6x. So now I can substitute. I'm going to have 4 times negative 6x plus 6x minus 9 all over 2x plus y cubed. And then 6x plus 6x is nothing. That entire term disappears and becomes a 0. So my final answer for the second derivative is this. D squared y dx squared is equal to negative 9 over 2x plus y quantity cubed. That problem was very intense on the algebra, and you will only have a few that you have to do like it. Most of the problems are similar to example 1 and 2. Your homework related to this lesson is on page 147. You are going to do problems number 45 through 50, as well as 53. But I would like you to do problem number 46 last, because it is the longest and most challenging problem. It is the most similar to the one that we just went over.